So today we're going to cover section 3 of chapter 2, and today we're going to learn how to use postulates and diagrams. So here are the first 4 postulates of this lesson. Again, do not memorize the numbers because on a test, I'm not going to ask you name or list postulate 2.1. I may say, tell me what the 2-point postulate states, or give me an example of it, but I'm not going to ask you to name something based on its number. So the first one is called the 2-point postulate, and all this postulate states is that through any 2 points, there is exactly one line. And really, we already saw this in chapter 1 when we learned how to name a line. So for example, if I draw a line or draw 2 points, so like for example, if I say if you have 2 points, A and B, then you could say then through those 2 points is exactly one line. And you could say that through those 2 points is line AB. The second postulate is called the line point postulate, and this one states that a line contains at least 2 points. So that means that there has to be at least 2 points on there. There could be 3, there could be 4, but if you remember back to chapter 1, in order to name a line, you need 2 points, or you need to name it with that lowercase letter if there was one next to it. So if I drew a line here, and I had points A and B again, but technically it could also have C, it could also have D. You need a minimum of 2 points to name a line or on a line. The third one is called the line intersection postulate. So for example, if you have 2 intersecting lines, then their intersection is exactly 1 point. So they could first show you the 2 intersecting lines, but then they could show you that that intersection is exactly 1 point. So on the quiz, I'm going to be giving you diagrams, and you have to give me the name of what's being pictured. And then the last one on this slide is called the 3-point postulate. And this one states that through any 3 non-collinear points, there is exactly one plane. And again, a repeat of chapter 1, where we learned how to name a plane. So if I draw 3 points, and they're all not on the same straight line, they're non-collinear, we can also put those 3 points in this plane, and we could name the plane. So we could call this plane ABC. So through any 3 non-collinear points, there is exactly one plane. So that would be your final picture there. And remember, a postulate is determined from a definition or from a rule. We have 3 more postulates on the next slide. So our next 3 postulates are on this slide. The next one is called the plane point postulate. And what this one states is that a plane contains at least 3 non-collinear points. It can be more than 3. But remember, you need to find at least 3 that are not on the same line to name a plane. The next one is called the plane line postulate. And this one states that if 2 points are in a plane, then the line that contains them is in the plane. So for example, if I draw a plane here, and let's say I put 2 points in here, points A and B. So if 2 points are in a plane, then I could draw the same plane with the 2 points. Then the line that contains them, line AB here, would also be in the plane. Now we'd need a third point here. that would be not on the same line to name the plane. And then the last one is called the plane intersection postulate. And this one states that if two planes intersect, then their intersection is a line. So for example, if I translate this, so if, and then let me draw two planes here. So these are my two planes. I got a blue one and a red one. And then, so if I start out by saying if two planes intersect, then I'm going to draw exactly the same two planes again. And then I'm going to show where their intersection is. So then their intersection would be a line. And it's here in purple. So this would be a demonstration of the last one, the plane line, the plane intersection postulate. So perpendicular figures, here what it's talking about, a line is perpendicular to a plane if and only if, oh look at this, if and only if, this is a biconditional. The line intersects the plane in a point and is perpendicular to every line in the plane that intersects it at that point. And the way that we can tell that something is perpendicular is this little right angle that's pictured here. Without this little right angle, or without them have been telling us that maybe AP is perpendicular to line T, we couldn't assume that it's perpendicular. So we need to look for right angles to indicate that they are perpendicular. So this is telling us that line T is perpendicular to line AP, and it's also perpendicular to line Q. And we can tell that by the right angles. The symbol for perpendicular is an upside down T. So if you ever see an upside down T, that's referring to the lines being perpendicular. So in this particular picture, you could have stated that line T, and then they would put the upside down T is perpendicular to AP. Or you could have replaced it with line Q. So that's how you can tell if they're perpendicular. You're looking for that right angle. So for the first example, notice it's stating that if, and then that's a picture of two lines that are intersecting. Then their intersection is a point. So this is the line intersection postulate. So line intersection postulate. And what this postulate states is that if two lines intersect, then their intersection is exactly 1 point. The next one is an example of the plane intersection postulate. And what this one states, that is if two planes intersect, then their intersection is a line. And that's what happened after the word then. You can see that the line is in red, indicating they're showing that intersection. So be able to take a diagram like this and state which one of the 7 postulates are pictured. So example 2 wants us to use the diagram to write examples of the plane point postulate and examples of the plane line postulate. Now, when they tell you to use the diagram, they want you to describe specific information from the diagram. So let's take a look and answer the question for the plane point postulate. Remember, the plane point postulate states that a plane contains at least 3 non-collinear points. So what I'm going to do is I'm going to look at my diagram, and I could state that plane P contains at least 3 non-collinear points, and I'm going to name those 3 points, A, B, and C. That would be an example of the plane point postulate using that diagram. Now they also want me to give an example of the plane line postulate, so I'm going to write that in green. Remember, the plane line postulate states that if 2 points are in a plane, then the line that contains them is in that plane. So let me come up with some points here. So for the plane line postulate, I could say that point, or points A and B, lie in plane P, so then line, you could either call it line N, or you could call it AB with the line on top, either way, containing points A and B, also lies in plane P. So because points A and B are in plane P, then also the line that contains those points, which is line N, or you could name it line AB, is also in plane P. Okay, so for example 3, it says, which of the following statements cannot be assumed from the diagram? So remember, never assume, okay, anything. You have to look for the appropriate markings, the appropriate measures, things like that. So the first statement is A, B, and F are collinear. So let's find out where A, B, and F are. So A is here, B is here, and F is here, and they are all connected with a line. So this one, yes, you can conclude that A, B, and F are collinear because they are all connected with that line. However, E, B, and D, they sort of look like they're on a line, but they have not drawn in a line connecting them. So without that drawn in there, you cannot assume that they're on the straight line. So this one would be no. The next one, remember that upside down T is the symbol for perpendicular. So it's telling us that line AB is perpendicular to plane S. So let's find AB. So AB is right here. Plane S is the red one. And notice where line AB is intersecting that plane, there's a right angle. So yes, I can conclude that AB, that line, is perpendicular to plane S. However, CD, notice this thing over here, notice there is no right angle there, so I cannot assume that that is perpendicular. Since it's missing the right angle, you cannot assume it's a perpendicular line. And then the last one, line AF intersects line BC at point B. So here is AF, here is BC, and yes, they do. Those two lines intersect at exactly point B, So this one is yes. So for the last example, we're bringing back chapter 1. So in chapter 1, we learned what a vertical angle was, and we also learned about supplementary angles. So remember, vertical angles, they're formed when two lines intersect, and then the rays or the sides of those angles form opposite rays. So let's go ahead and find our vertical angles in the picture. I've got two pairs. So I have a vertical angle right here, PWV, along with TWQ. So these would be your two vertical angles. Here's one pair. So notice that there's a whole bunch of angle W's here. So I cannot name these vertical angles with one letter. I have to use 3. So when I go to name the verticals here, I'm going to name this first one as angle PWV together with angle TWQ. Now again, you can do it in reverse. You could have also called it VWP, and then this one QWT. So this is the purple ones. And then I can also find some over here on the other side. These are also vertical. And again, I'm going to name them with 3 letters. So I'm going to name it, the other pair would be PWT, don't forget the angle symbol, together with angle VWQ. And again, I could name them in reverse, TWP, and then angle QWV. These are the vertical angles in the picture. Now there's a bunch of supplementary. So remember, supplementary, when we have a picture like this, really what we're looking for also is a linear pair. Because remember, supplementary angles add up to be 180 degrees. So let me go ahead and I'm going to write the supplementary down at the bottom, or maybe over to the side. So I'll write my supplementary. Okay, so for my supplementary angles, I could start here up at the top, and I could do PWV along with VWQ, because notice they're both sitting on this straight angle. So I could say angle PWV together with angle VWQ. And again, you can name it in reverse, VWP, or this one in reverse, QWV. So this is your first pair of supplements. Now, we could also keep going around. So then I could also come over here and grab this one, the one I just used, with this one. So again, I would name this one as VWQ together with QWT, or in reverse, QWV, and this one in reverse, TWQ. That would be the orange ones. Then I keep going around. So then I can also come here now with this last orange one, with this one over here. So then that one could be angle QWT together with angle TWP, or in reverse. So that's another pair of supplementary. And again, remember, these are linear pairs. And then I can go around one more time. And I can, let's see, maybe I'll go pink here. I can do the same one that I just did here, along with this top one. So the last one could be angle PWT together with angle PWV, or in reverse, TWP and angle VWP. So these are all the supplementaries. So Obviously on the quiz, you're going to look for the choice if I give you a question like this because it's multiple choice. Okay, so as you see, there were multiple answers for the vertical, multiple answers for the supplementary. So if ever I give you a question on a test or a quiz and I say, give me one, give me one. Don't give me more than that, because if you give me two and one is wrong, you lose everything. So give me the one that you know for sure, unless I ask for more than one.